All right, so question number 7 is us finally getting to the SUVOT problems. And I just want to remind you that there are certain keywords we're going to look for in deciding initial values, or just this thing here where we're going to fill out these variables first. And then we're going to use that to figure out which equation we pick to solve for the unknowns. So I actually looked this information up for real. It actually turns out a 747 starts from rest, and it actually does need to get up to 80 meters per second in order to take off. And this was the acceleration that I happened to look up. And we want to calculate the distance it needs to travel in order to reach the speed from rest. And we want to know the time it needs. So let's just be clear. We don't know the distance. We know it starts from rest. Remember that clue. Starts from rest means u equals 0. So we're going to get up to a speed of 80 meters per second. So that's v. We're given an acceleration of 2 meters per second squared. And we don't know the time. So that's actually enough for us to start solving problems. So it says calculate the distance it needs to reach the speed. Let's go ahead and see what we can do. So I don't have the time yet, so I'm going to go ahead and actually use the equation that doesn't have time in it. So v squared is u squared plus 2 times a times s. That's 80 squared equals 0 squared plus 2 times 2 times s. That's giving me 6,400 equals 4 times s. And when I divide by 4, that will actually give me s. And so that means 1,600 meters is the distance that the plane travels. All right. Now let's go ahead and get the time that it takes. So I'm going to get v, I'm going to use the equation v equals at plus u because it's easy. So I know that 80 equals 2 times t plus 0. When I divide both sides by 2, and let me just simplify this further, 80 equals 2t. I'll divide both sides by 2, and I'm getting 40 seconds equals the time. So those are my two answers for part A. Let's go ahead and do part B right now. So a car is moving at 20 meters per second. It needs to stop before hitting a wall 50 meters away. We want to know the value of the braking acceleration it needs in order to do this and how much time it will take to get to the wall. So we're going to assume that it's going to come to stop or come to rest before it hits the wall, so v will be 0. I know that it's traveling 50 meters because that's given in the problem, and it starts off at a speed of 20 meters a second. We don't know the acceleration, and we don't know the time. So let's use the equation that doesn't have time to get the acceleration. So I'll use v squared is u squared plus 2as. I end up at a final speed of 0. That's going to equal 20 squared plus 2 times a times 50. And that's going to give me 0 equals 400 plus 100 times a. I'm using commutative property and other neat tricks from algebra. I'm going to subtract 400 from both sides. And that's going to give me negative 400 equals 100a. I'll go ahead and actually divide both sides by 100. and that's going to give me an acceleration of -4 meters per second squared. So there's that. Now, I've got the acceleration. I'm going to go ahead and get the time. So here's the acceleration, and I can use v equals at plus v naught, or plus u, sorry, wrong class. So that's going to be 0 equals -4 times t plus 20. I'll subtract 20 from both sides, and that's going to give me -20 equals -4 times t. We'll divide both sides by -4, and we're going to get that t is 5 seconds, just like that. All right, so that's part B. Let's go ahead and move on to part C. So an object falls from a cliff from rest. How far does it fall after 6 seconds, and what is the final velocity? So let's be really clear on this. When something falls, that means the acceleration is happening because of gravity. So that's 10 meters per second squared. And in this class, we're just going to do problems where it's always a positive 10. When you take advanced classes like IB and AP physics, they will actually play with axes and Cartesian coordinates and all that, so that you'll have to worry about that. I want to keep these problems sort of basic. I want to challenge you, but there's a lot to cover this year, and this just is one detail that I'm kind of choosing to gloss over because it's easily figured out later on. So I don't know how far it's going to fall. Starts from rest. That means u is 0, v is unknown, a is 10, and t is 6 seconds. So let's get how far it falls. So s is 1/2 at squared plus u times t. That's s is 1/2 times 10 times 6 squared plus 0 times 6, so that's 0. So I'm going to end up getting s is, when I put this in my calculator, 36 times 5, which is 180 meters. Now let's get the final velocity. V is at plus u. V is 10 times 6 plus 0. So V ends up being 60 meters per second. Excellent. All right. Now, the next thing is that we have a car traveling very quickly, and it slams on its brake and skids to rest. The skid mark is 40 meters long. We've got a braking acceleration. We want to know the initial velocity, and we know the time. And we want to know the time it took to come to rest. So, with this idea here, S is 40 meters. U is unknown. We don't know the speed it started at, but we do know it came to rest. A is 2, and the time is unknown. So let's go ahead, and we don't have time, so I'm going to use this equation. Oh, one other thing. Since the car is going forward and the acceleration is trying to push it backwards to stop it, we'll make it a -2. So v squared is u squared plus 2as. So we have 0 squared equals my unknown u squared plus 2 times -2 times 40. And I think this is where people got a little confused. That negative sign makes things better. So I'll actually subtract u squared from both sides. I'm going to get -u squared equals, and when I multiply this stuff out, it's going to be -160. I can multiply both sides by -1, so I'll get that u squared is 160. And I'll go ahead and take a square root there. I know some of you were sort of being a little loosey-goosey with your square roots and decimals. I'm just going to go ahead and work it out to get a decimal number. and I end up getting an initial velocity of 12.65 meters per second. Again, I'm not paying attention to sig figs. We're going to start doing that in the next unit a little bit more carefully. And we want to know the time it took to come to rest, so we'll go ahead and do that here. So we'll say V equals AT plus U. 0 equals -2 times t plus my initial speed, which I got as 12.65. We're going to subtract 12.65 from each side. And so we end up getting -12.65 is -2t. We're going to divide both sides by -2. And that's going to give us a total time to stop of about 6.3 seconds. All right. So that is question number 7. And I'm going to go ahead and work out the extra credit questions in the next set of videos. Actually, I'm going to do 2 videos, one on extra credit question number 8 and one on extra credit question number 9.